we'll start. So this is the second project, and when you guys have any question, just feel free to ask and whenever. So the second project of the goal, the goal of the second project is to train custom language model using transformers decoder and recurrent neural network. Yeah, so the goal is to check if you guys can use various torch functions you've learned so far during the training session. And this custom language model combines transformers, decoder layers, and vanilla recurrent neural network. And it is important. Could you do? Okay. Is it better? Yeah. So, you should note that it is not a typical architecture that which is used in language models such as like ChatGPT, this kind of stuff. But it's just a twin model to assess the ability of your ability to write PyTorch code combining various torch functions. And the architecture will be in this order. So first of all, there's transformer decoder layer, and then RNN, and one fully connected layer, and lastly, another transformer decoders layer. And we'll see in detail in section 3. And the dataset we'll use is AI5 dataset. And we provide the processing code that was dealt in the training session. So like concatenating texts, coding them into predefined context length, and tokenizing and converting to tensors. All of this processing code will be provided. So you don't have to code with this one. And so when we process the code, there is total 14,000 training data set and 5,000 validation data set. And each sample's torch length will be 200. So the sequence length you should train your model is 200. And there is 4 code implementations that you need to do. And the first 2 are writing the internal structure of the language model. And third is to write the training code. And the fourth is to write the evaluation code. And yeah, so this is how the language model should look like. So as I told you, first of all, there is one transformers decoder layer, and recurrent neural network, and one fully connected, and another decoder layer. Okay, so the configuration is like, so for the decoders, there are 2 decoders, and each having 3 decoders layers. So there are 3 decoder layers, 1 each. And in between the decoders, there's a vanilla recurrent neural network and a fully connected linear layer. So 1 RNN and 1 fully connected. And each decoder layer, for each decoder layer, the embedding dimension is 128. And the dimension of the feed-forward network is 512. And there are 4 attention heads in each layer, and the dropout rate is 0.2. So the language model's maximum position embedding size is 200. So we already set in here to be 200, the training set and validation set. And we provide 4 codes: multi-head attention, position-wide feed-forward, sinusoidal positional embedding, and decoder layer. So we provide you the code that was already done in the training session. And for the RNN, so for the recurrent neural network, there are 3 layers within. So 3 layers within the recurrent neural network, and the hidden size of RNN is 64. And you should note that the RNN module does not take the initial hidden state. It only takes the input. So which means it only takes the decoder layers, 3rd decoder layers output. And after this RNN layer, fully connected layer is applied to match the dimension. So for the configuration. So the embedding size 128, which means this one. Decoder layer is embedding size of 228, and feed forward network, the embedding size, dimension size is 512. So this one, and attention has 4 attention heads, and dropout rate of 0.2, and maximum position embedding is 200. Non-decoder layer 3 for each decoders, and RNN hidden size is 64, and number of layers is 3. Where is it? Yeah, 3. And the vocab size is definitely, of course, the length of the tokenizer. Any questions so far? Um, there are any more details about layers for positional embeddings, residual block? Are they? Yeah. So for this, for sinusoidal positional embedding is already in the skeleton code, so you don't have to write the code for the embedding. I mean the positional embedding. What does it mean takes only input? It doesn't mean it does. Does it mean sequence output? So RNN takes two kinds of input. So it takes the input tensor and the initial hidden state. But if you don't give the initial hidden state, it is like it's zero for default. So don't give the initial hidden state as the input. Just the, I mean only the input tensor, which will be the output of the decoder later. Yeah, of course, skeleton code will be offered. Yeah, H0, so the initial state, hidden state, H0 is zero vector, zero tensor, but you don't have to give it. If you just don't put it in the argument, it will send 0 as default. So you don't need to send it. Yeah, so you don't need to give the input H0. If you just keep it blank, it will just automatically set 0 as default. Yeah, RNN is unidirectional. It's vanilla RNN, not bidirectional. Yeah, you're right. Okay, so the first thing you need to do is this one. So this is the custom language model class. And the first thing you need to do is fill in this percent mark. And you should note that you should not add additional functions in here or change the sequence, change the order of functions defined. For example, if you change the self embeddings and self position embeddings first and second, it will change the result. So do not change this order. What you need to do is just fill in this config dot blank. So you should so this key should come from this one. So like nn dot embedding config point embedding dimension ffn dimension, like this kind of stuff. So you should then fill here, 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 here. This is not config dot, so I just didn't put there. And linear layers, oh sorry. Here, here. Yeah. And how many things? Yeah, so you should fill in the blank. And the second thing you need to do is use these functions and this generate mask to do the forward pass. So the input of custom language model takes tokenized IDs and a size of batch size and sequence length, and the output should be logits, batch size, sequence length, and vocab size. And you should use all of these functions and generate mask function in this forward pass. So these are two to-dos among the 4, and I'll take questions. No question? So as I told you before, this sinusoidal positional embedding is already given. Also the decoder layer. So all these four functions are given. You don't need to do anything with this. Okay, for the module initialization, yes, you don't need to do the module initialization. So there are only two duties in transformer parts. Yeah, in this, so there are four, and two of them are here. This one, to do first, this one, and to do second, this one. And there are 3 and 4, so training and evaluating. But for the forward call, you need to implement from scratch. Yeah, you should use these functions and generate the mask to do the forward pass. So for the first two, you just fill in this blank. That's all. And second, you need to from scratch all of them. Yeah, I hope everybody understood. And so, so the third thing and fourth thing is training and evaluating. This just is simple. I think there will be no question for this. Does 3 RNN layers affect the internal function, or are you stacking 3 separate? If you see this code, there's only one RNN. So I'm just defining RNN with 3 layers. I'm not stacking 3 separate layers. I know what you mean, but just, yeah, just you should use only one of these. Not you should not define this 3 of them here. So here is already the num layers arguments. So yeah. Do we need to worry about the C during training? So there's already the function in the code that uh, fixes the seeds, but if you change this order of the function, like for example, if you change the self.fc, if you move self.fc first and self.rnn next, and it will change the loss a little bit. So this is why I told you to not change the order of the function order. Just fill in this blank. That's all. If you do this, yeah, and the loss will be same. For training and evaluation, we can do exactly the same as the practice session, right? Since there aren't any specific direction. Yeah. Well, actually, there's only one way to do the training and evaluation code. So yeah. We already give you what kind of loss function up here. And yeah, it's of course defined. The loss function, optimizer, everything is defined. Okay. So we provide the skeleton code and this Jupyter notebook, and you should first change the file name to your student ID. So there were a lot of like you should change the file name to only your like student ID. If you don't change, if there's any additional like punctuation or this kind of stuff, it is we will not grade it. And so this step is same as the first project, so I will not explain it in detail. And so if you just complete your code and run this file, it's same. It will output loss and it will make the result txt file. And if it doesn't, don't worry, it's just a collab error. So if you don't change the part that saves the results text file, and you don't have to worry about whether the collab is the Jupyter notebook is making this result text file or not. And so for like using Google Colab environment, using T4 GPU, when seed is set to 1 and stop epoch is set to 0, the validation loss falls between this range. And when seed is 2 and epoch is 1, the validation loss falls within this range. And when you use the CPU option, when the seed is 0 and stop epoch is 0, the validation loss falls in this range. But you should note that running with CPU takes 2 hours just for one epoch. So use this option only if you cannot use the GPU due to timeout. And of course, you must have enough time for this. Could you share the expected runtime for GPU? For GPU, like like 5 minutes, 5 to 10 minutes. Yeah. So for this one, like 5 minutes, and for this one, like 10 minutes. But it depends on how many users are using Google Colab. So like if you do it in the night times, it's day in US, so it'll take more. If yes, but yeah, normally 5-10 minutes and 5 minutes. Yeah. So notice, do not install additional Python libraries, and when submitting on KLMS, just only submit the renamed student ID file. So like no this kind of stuff, no, and or something else, just your student ID. And do not submit any other files or compressed files, only Python script. And do not modify anything other than the to-do section. And this time, the KLMS will close at exact due time, which is tomorrow, 11:55 a.m. It will close at exact time, so there is no room for any late submission. And most importantly, this time we will not answer questions that have already been covered in this session, or questions that was already dealt in the classroom. So if you have any questions, you should first check the classroom if that problem was already dealt. Okay, so when project one calculates the value from Google label, there was a phenomenon that the loss value changed over time. Will the validation currency study? Well, Seokju, I think you're wrong. There's there's no chance that the loss value changes over time. If your code is same. Yeah, of course, of course. Okay, then I will run the exact answer code tomorrow, and if there's any change with this range, I will update it. I'm sorry. Okay, in forward function, not init function, should calling order embedding not affect for results? Yeah, the calling does not affect the results. Is there more detail on the training and eval function? Are we clip? Nothing else. Just basic training. You don't need to clip. You don't need to do like addition. Like you don't need to do the learning rate scheduler. Nothing else. Just I think for this part you can just refer to the training session code. It's the same. So this is it, and I'll take questions from now. If you can question with your microphone, whatever you want. When is the last time you validate the loss range? Can I assume that this is correct until today? I validated today morning. but I will do again today's night and tomorrow's morning. So if there's any change. Yeah, this the video will upload it, but it takes time to encode this the video, so it'll take like 1 hours maybe or 2 hours. Could you please tell us the estimated training time if, for example, based on I already told you. It's 10 minutes for this one and 5 minutes for this one. I mean 10 minutes for two epoch, which is this is yeah, and 5 minutes for one epoch. Can we check the result when? But can we check the result when epoch after stopping it? There's argument. So if you give argument here, it automatically stops. It breaks the for loop. The structure of the code is same as the first project. Just the contents are different. But it will stop before the max defined. Yeah, of course. The max epoch is set to 20, I think. Was it 20? Yeah, it's 20. Yeah, it's same as the first project architecture, and it will be also same for the third project. So yeah, then we should change the stub parameter to check the number three is not concerned. The number three is not concerned. Yeah. So when you want to check this one, you change C to 1 and stop epoch to 2. That's all. So this one goes here, and this one goes here. What are the dictionary values of the dataset? What do you mean the dictionary values? I didn't get it. Is it okay to put some print message for login? Yeah, it's okay to put some print messages. Um, yeah, it's okay, but you should not change the below part that is like, I mean, like result. What is it? Like saving the results text file. Are you going to upload the set of codes at noon, aren't you? I will upload it at 12 o'clock this noon, yeah. I mean 11:59 to be exact. So when you check the test suites, you will use the same seed and we talked to call R6, right? Like last time by chance. Yeah, you're right. Xiangqi. We will change. We will for evaluation. We will change this stuff. These one. It's still like in the dem. It's still source and target like in the demo. Uh, is it still 100%? Ah, oh, actually, I didn't get exactly what you're talking about, but for the data set, it's the same processing. It's the same processing that was dealt in the BERT and GPT session. So you can refer to that. The data set and processing code is the same as the session that we dealt in BERT and GPT session. BERT GPT. no questions, I will take questions until 11. And you said to refer to the practice session for training eval. Did you mean BERT session as well? Yeah, I meant BERT GPT session. I guess the previous question, sorry. Structure of training functionally are exactly the same as project one. Is it okay to implement the same to project two? No, the whole structure of the code is similar to project one, but training and evaluation function detail is different because the first one was about images and the second is on the texts. So the function could not be different. Right? Could not be the same. Okay, okay. I'm sorry to bring this up question again. I messed up, but you said yes to this question. When you said to refer to purchase action training, you mean to Bird GPT precision? For training and eval, you you should refer to Bird GPT session. But for the whole code, you should refer to transformers and Bird GPT session, both of them. Because yeah, these four functions are directly from the transformer session. Okay, I think I can end this here. So uh, the files will be uploaded like 1 hour later from now, and the due date is tomorrow, 24 hours later from the initial. And yeah, so please note that this time the KMS will close at the exact time. So if you're like 30 seconds late, it's F. Be aware of it. Okay, guys, I hope you do good with this project. And I experienced the machine of collab change after midnight. I don't know exact policy of collab, but I hope to loss. Yeah, I will. I will update the range. But actually, even though the internal structure changes a little bit, it will still fall within this range. But I will keep it in track, and if there's any modification, I'll let you know and upload on the classroom that it changed. Don't worry about it. Yeah, okay, guys. Uh, I'll end this here and hope you do well. Bye bye.